So we have started to discuss about VLANs and trunking, dynamic trunking protocols, right? So previous class we have discussed what is VLAN and why VLANs is required to create in your network and what is trunking and dynamic trunking. Can anyone please explain me about VLANs? About few points about VLANs. What is VLAN? Why VLANs do we create? What the advantage of VLANs and trunking and dynamic trunking?
Hello, I have a quick question, Balu. Can I?
Yeah, please.
I just have a small doubt on the VLANs and access tagging, trunking, and dynamic. Can you quickly go through and
Okay.
I went through your last class. I missed it. I went through the entire recording.
Okay.
I thoroughly gone through, but quickly, can you briefly just describe all this? In VLANs, we have segmenting and isolation of traffic.
Yeah.
Parallelly, we have even subnetting also where that gives us the segmenting of networks and isolation of networks.
Yeah.
How VLANs and subnets are different and access, how does it, where does we actually use this? Tagging, trunking and dynamic. Just quickly, if you can brief me, I'll be glad.
Yeah. Sure. Good question. I like permission. No problem. I'll explain it again. See, we consider the switch A, port number 1, port number 2, port number 3. Like it's a 24 port switch. In port number 1, have device connected. Port number 2 device. Port number 4 and port number 5. Port number 1 and 2. First two computers, let's consider sales department. Two different departments in my switch. Like for sales department, I'm using network is 1.0 network. Means 1.10, 1.20 IP addresses. For HR department, 2.0 network. Like 2.10, 2.20. It's a layer 2 switch. Now, sales department users and HR department users, will they communicate? No. Why?
Because they're in different networks.
So because of they are in different networks or different sub-networks, whatever, they are in different networks. Okay. Now HR department 1.0. Sales department 1.0, HR department is also 1.0, but sales department are in VLAN 10, HR in VLAN 20. Will they communicate now?
No.
No. Why?
Different VLANs.
Different VLANs. So before scenario, two departments and two different networks, they don't communicate. Now this scenario, both are in same network but different VLANs, no communication. But the same thing, the same question you asked me. So instead of creating VLANs, if you make in the different subnets, then why VLANs is required? The different networks are different subnetworks, they don't communicate. The department wise segmented. Then still why we wish to create VLANs? Now they don't communicate. Before scenario also no communication. Why? Still why we require VLANs?
Port security. I don't know.
Yeah. See, before scenario is both are in a different subnets, right? Example.
Updating is in routers and
2.0. Okay. Now, sales department in 1.0, HR in 2.0, right? Different networks, same VLAN, default VLAN 1. By default, switch is in a VLAN 1. Now port number 1, port number 2, port number 3, 4, 5, 6, like all ports, 24 ports in the part of VLAN 1. The point is, now when sales department and sales department trying to communicate, so broadcast will happen in HR department also. So switches will do irrespectively broadcast if they are in the same subnet or different subnet also. And the broadcast happen to all the enter the whole switch. Even sales are in 1.0, they don't communicate, but broadcast happen to 2.0 department also, remaining rest of all the ports. But once you make a VLAN 10 for sales department, VLAN 20 for HR department, now broadcast happen only for two computers.
Good. Yeah.
So by creating VLANs, we are minimizing the broadcast in the network. And we are providing security for your network department wise. So if you not created VLANs, the broadcast happen to hold the switch. Means other department also unwanted risk in the broadcast. Now other departments can be monitored what they are exchanging. It's not secured. Unwanted broadcast coming to other departments. If switch B is connected, so that will come to switch B also. Broadcast will come to C also. Broadcast will come to enter the switches also. The major two advantages of VLANs is to minimize the broadcast domain. Now if we create the VLANs for sales department for first two computers, the broadcast happen to only 1-2 ports. It is not going effective to remaining all the switches. And securely they can communicate. So this is a major advantage of VLANs is minimizing broadcast and providing layer 2 security.
The access and tagging?
Yeah. Is it clear for everyone? VLANs about? Parmeshwar? Stravan?
Thank you. Yeah.
Yeah. So next scenario is now let's consider same thing. So now I have explained in the only one switch in switch A. Now what if you have a switch B also? Like switch B. In next switch, what if I have the same department? So switch B sales is there, switch B HR department is there. Then how can allow switch A sales users to switch B sales, switch A HR to switch B HR? Like do you need to maintain a links for sales to sales one link, HR to HR one link, like VLAN 30, VLAN 30, VLAN 40, VLAN 40? No need to be multiple links. So I'm using only one physical link between the two switches. So this link by default allows access. This link is the access link first, initially. Access port, access link allows only single VLAN traffic, VLAN 1 traffic only. So where you are connected uplink port, switch A port number 24, switch B port number 24, right? So A24, switch A24 by default mode is a access mode. Even B also access. So access port allows single VLAN traffic only, means VLAN 1 traffic. But what is our requirement? VLAN 10 traffic should come to switch B VLAN 10, VLAN 22, VLAN 20, VLAN 32, VLAN 30, like multiple VLAN traffic has to be allowed, right? So to allow the multiple VLAN traffic, we need to configure trunk. So trunk port allows multiple VLAN traffic. So if we configure trunk on the both sides, what trunk port will do? So trunk port allows multiple VLAN traffic by adding a headers to Ethernet frames. So whenever traffic is coming to trunk port, what trunk port is doing is adding the tags, is adding the headers. That method we call trunk encapsulation. Two protocols, ISL and .1Q. ISL is open. ISL is a Cisco proprietary protocol. .1Q is open standard. ISL header size is 30 bytes. .1Q header size is 4 bytes. So if header size is simple, fast communication. So Cisco is also using by default 802.1Q. So here 802.1Q protocol. Here also 802.1Q protocol. So what this protocol is doing is adding the tags, is adding headers. So inside the tag, VLAN ID will be there. So switches will identify the traffic based upon the tags information. So VLAN 10 traffic is coming to 24. VLAN 10 traffic is adding V10 tag. Both are forward to B. Now what will B will do? Based upon the tag information, switches can identify data is belongs to which VLAN. Then tag is removed, data broadcast to VLAN 10. So trunk mode allows multiple VLAN traffic by adding a cadence. This is trunking. Next point is dynamic trunking. If both are Cisco switches, switch A is a Cisco switch. If B is also Cisco switch, both are Cisco switches. In switch A and B, both sides need to be configured trunk. Only one side if you configure trunk. One side if you configure trunk, other side automatically trunk will be formed. In Cisco switches, because of in every Cisco switch by default, VTP protocol is enabled, dynamic trunking protocol. So dynamic trunking protocol is the responsibility of sending automatic negotiations, sending auto negotiation messages. Like once if you configure trunk, what trunk code will do? Will negotiate, automatic negotiates, will send the messages. You form a trunk, you form a trunk. Other side mode is what? Auto mode, dynamic auto mode. So this dynamic auto is passively waiting to receive the trunk negotiation messages. Whenever dynamic auto receives, it forms the trunk. So by default, all Cisco ports are dynamic auto mode. Dynamic auto is a passively waiting. If dynamic auto port receives the negotiation message, form the trunk. So one side if we configure trunk, it sends the negotiation messages. Other side is passively waiting, it form the trunk. Like this. So dynamic trunking between the switches. Switch A to B between the switches, dynamic trunking means one side if you configure trunk, other side automatically trunk will be formed. It's simple, a small feature about in Cisco devices. So this is the overview about VLANs and trunking and dynamic trunking. It's clear?
Thank you, Balu.
All right.
Why DTP is unsecured? Is meaning it is not secured data transmission, or is it vulnerable to?
Yeah, yes. Actually, we have some default protocols is enabled in Cisco. Unused services. Whatever you're not using the services, that better to disable. So because of switch MAC flooding attacks will be there actually, MAC some attacks will be there. So DDP is one of vulnerability. By default, dynamic auto mode is enabled, right? Some attacker has been connected to our switch. So our switch mode is what by default, dynamic auto mode is enabled. Now what attacker will do, they'll use some softwares. By using some softwares, he will send negotiation messages. So whenever trunk negotiation message will be sent, dynamic auto will form trunk, right? So between the hacker switch and our switch, trunk will be forming automatically. So once trunk is been formed, now all our users traffic will go to hacker. So unused services we better to disable. This is one of the vulnerability in dynamic DDP. Okay.
Thank you.
All right. So let me continue with next scenario is a between the three switches let me discuss here. with 3 switches. Switch A, switch B and C, 3 switches. By default, switch A is in VLAN 1. Even switch B is also VLAN 1. C, VLAN 1. So in this picture, total how many broadcast domains is it? Switch A is one domain, switch B is another, C is another, right? So 3 broadcast domains in this picture now. I have connected a link between switch A to switch B. Now how many broadcast domains in this picture now? 2 broadcast domains. A, B belongs to one domain and C is another domain. Now if you connect a link between switch B to switch C, like total how many broadcast domains in this picture? So physically there are 3 switches, but once you connect the link between the switches, now all 3 belongs to only one domain. So from anywhere, from any switch, any broadcast packet is being generated is going to broadcast to all the switch, right? All 3 switches. The broadcast domain is big now, like 72 ports. Then how can minimize the broadcast and how can provide the security in the network? What is the solution? How can
VLANs.
minimize the VLANs? How can minimize the broadcast?
VLAN.
By creating VLANs, yes. Okay, we need to segregate our network in smaller broadcast domains. Okay, now what network administrator job, what network admin is doing is to minimize the broadcast in the network and to provide the security, he has to create VLANs. A network administrator is logged into switch A, it's creating VLANs is VLAN 10, VLAN 20, some VLANs is being created, 50 VLANs. Same VLANs, like same departments, what if have in A, switch B also. Now network admin log into B and create V10, V20, V30, 40 and 50. The same have a switch C also. Now administrator log into C and here also have to create 20, 30, 40, 50 VLANs. So 3 switches and 3 times you log in and create it, right? Now what after some time you want to delete a VLAN 50, then log into A, no VLAN 50, log into B, no VLAN 50, log into C, no VLAN 50. And you want to modify 50 as a 55 and log into A, modify 55, then log into B, log into C. So now what if you have a 100 switches connected network? Like in your network, there is 100 switches is there. All 100 are connected. The network administrator task is more work, administration is work. So every switch want to be logging and creating and deleting and modifying every time. It's a problem, right? So to overcome this type of issue, we have a very good protocol in Cisco, which is VLAN Trunking Protocol, VTP. We can take the help of VTP. So VTP is to create a VLAN configuration consistency throughout the network. And throughout your network, you have hundreds of switches or 200 of switches. VTP helps. So how VTP works is, by default, every switch is in a VTP server mode switch. VTP modes. VTP server mode. VTP client mode. By default, switch A is a VTP server. B also, C also, like every switch is by default is VTP mode, server mode. Switch A is a server mode. B also server mode. Switch C, every switch by default server mode. Then what we are doing is, instead of creating a server mode, let me change C is a client mode switch. Let me change B is a client mode. Like remaining rest of remaining all switches, let me change the client, and let me keep A is a server. So switch B have changed the mode is client mode. C also client mode. Now, if we create VLANs in server switch, VLAN 10, VLAN 20, VLAN 30, VLAN 40, like VLAN 50. So if we create a VLANs in server switch, same information will be replicated in all client switches automatically. So what are the VLANs we are creating in this server? So what server is doing is the same information automatically is going to update to client B. Hello client B, I have one update for you. So what client B will do? It'll copy the information. The same information is going to update to next client. So what next client will do? Will copy the in switch and update to next switch, update to next switch, update to next switch. Like throughout the network is going to advertise to VLANs information in all the networks. Network administrator will no need to be create the VLANs in all switches. If we create VLANs in A, information is going to copy into all switches in network. So if we delete the VLAN 15 server switch, server will update to client. Client B have removed 50. So I'm also removing 50. I'm also removing 50. Like what are the modifications is done in server is going to replicate into all client switches throughout the network. If we create VLANs, if we delete VLANs, if we modify VLANs, it's going to replicate it. So that is what VTP used to create VLANs configuration consistency throughout the network. Dynamic reporting in all switches.
Balu, for this, the physical connectivity should be shared by all the switches.
Yeah. Come again, this type of?
Balu, for this feature advantage, for example, now B port, first port I have given VLAN 10. So
Yeah.
the physically in B switch and other switches also physical port is connected to the same VLAN category.
So no, ports are not implemented, only VLAN IDs. So ports manually have to manage. Yeah, just VLAN IDs only been copied. So here in switch B, yeah, junior administrators has been connected here. So junior engineers is connected here, right?
Okay.
So whatever junior administrators, VLANs will get from the server switch. After VLANs is being copied, so they can manage 1, 2, 3 or in 10 or 4, 5 or in 20. The ports will need to be managed manual again. Only we can get VLAN IDs.
So you meant to say that in all the switches, only VLAN will be configured, ports will not be configured.
Exactly, exactly.
Okay, Balu.
Yeah.
And one more question, Balu. This one,
Yes,
should we do it in trunk mode or any specific this one mode, where in dynamic trunk mode or just trunk mode?
yeah, I'm telling that. So here there is a 2 points is a VTP will works only on trunk links. And trunk links minimum is a 100 Mbps links. Then only VTP works. Your switch to switch links must be trunk. It can be normal trunk, it can be dynamic trunk. Anyone, trunk should be enabled. That is VTP means VLAN Trunking Protocol. So the switch links like uplinks is always should be what trunk links. If it's access link, VTP doesn't work. So this link should be trunk. This link should be trunk. And this trunk link minimum speed is a 100 Mbps links or more than 100 Mbps also. So that is then only VTP advertisements will be copied to client switches. Okay. The next point is here. Let's a problem is that. Let's consider some unknown switch is been connecting. Unknown switch. Let's consider hacker switch is being connected on network. hacker switch is Cisco switch. What is the default mode of hacker switch? For every default mode of every switch is what?
Dynamic.
VTP, server
Access
mode or
mode.
client mode, default mode.
Server.
Server mode. So now we have, now the hacker is come to our network. Now in a network, how many servers is there? Server 1 and server 2, hacker server, right? Now what hacker is doing is, like wantedly, he's creating some fake VLANs. VLAN 2, VLAN 3, VLAN 4, VLAN 5, VLAN 6, some dummy VLANs, some fake VLANs. Like more VLANs is created, thousands of VLANs is created. In which switch? In server switch. Now what server switch will do? It has to be updated to client. What client will do? The client will blindly be copy the information because of that VLANs is coming from server. I have to be copied. The server is a hacker server or office server, whatever secondary actually. What client switch will do? The update is coming from server, it has to be copied. So what client is doing is all thousands of VLANs is being copied. The same time is going to update to another switch. Now what client B will do? Copied, update to another switch. Like throughout the network, all switches being thousands of VLANs, dummy VLANs is being copied. So hacker is making our switches busy. Problem. So what if hacker switch is a client mode? The hacker is made change as a client mode. He's connected to our network. And what's the problem? So the network administrator, whatever the VLANs is created, network administrator. So office server, our server is going to update to client B. Client B will update to client C, and client C will update to what? Hacker. Now hacker switch automatically come all the VLANs. So what are the existing our VLANs? Hacker knows about what are the VLAN IDs we are running in our network. He knows that. Problem. So to overcome this, VTP server and client switches can be synchronized whenever VTP domain name and password has been matching the server and client, then only VLANs is being copied. So in server, we are going to create VTP domain name and password. Say VTP domain name is a Cisco, VTP password is CCNA. So these passwords and domain name should be same in all client switches. So we need to configure domain name and password in B. Configure domain name password in C. In all switches, configure domain name and passwords. And domain name passwords are case sensitive. So server domain name and client domain name. Server password and client password is matching. Then only VLANs is being copied. Synchronization happens. Then how hacker knows about what is the domain name we are running? And how hacker knows about what are the passwords we are running? Problem solved. Right? Yes. So VTP domain name and passwords are created. Now what about internal hackers? So some external you have added a switch, right? What about the internal? Like who is connected on your client switches? So some engineers are connected to client switches, right? So what these engineers will do? So already they have a logins in the switches. So now domain name and password is matching. This is existing in our topology, right? But internally inside our office there are hackers. So what the people will do? They log into switch and they're creating some fake VLANs again here. Or maybe they delete the VLAN existing VLANs. And what they will do? Update to B, update to D, update to D. Like throughout the domain again the problem. Internal hackers, right? So to overcome this type of issues, VTP allows to create VLANs or delete VLANs to modify VLANs when your switch is in a server mode only. So we can create VLANs, we can delete VLANs, we can modify VLANs when you are switching server mode. If your switch is in client mode, we cannot create, we cannot delete, we can modify. So creating, deleting, modifying only in server. When your switch is in the client mode, we cannot create, we cannot delete, we cannot modify that. So remaining, we can everything you can do. So port implementation you can do. Communication happens. So communication happens from server to client also, client to client also. So remaining everything is okay upon running. Only thing is we cannot create the VLANs. Creating VLANs is not possible. Like other protocols, we can do that. Like trunking, you can do like any other like only VLAN IDs we cannot create actually. We can implement the ports also. Yeah, this is how VTP server mode and client mode works. Cisco proprietary protocol create to maintain VLAN configuration consistency throughout the network. Provides VLAN tracking and monitoring, dynamic reporting of the VLANs. VTP only works when trunking is configured on fast Ethernet ports or higher ports. Switches should be configured same domain name and same password, and domain names are case sensitive. And VTP server switch role. VTP client switch roles. VTP server mode. The default mode. Create, can modify, I can delete VLANs. So what server will do? Forward advertisement means forward the information, forward the VLANs, and synchronize also, copying the VLANs. Client cannot create, cannot delete, cannot modify. Forward advertisement, synchronize. Clear? Shivteja?
అది కూడా చెవులో పెట్టుకుంటారు.
Now, so the next scenario. So next scenario is, like let's say in switch A we have sales department, HR department. In switch B, marketing department and ID department is there. And see again we have sales and HR. Out of 3 switches, where we can create VLANs? In which switch we can create VLANs?
Server. Server switch.
In switch A because of the server switch, right? Okay. So in server switch, I have created VLAN 10 for sales, VLAN 20 for HR. Now what server switch will do now? Update to client. What server will do? Forwards advertisements. Okay. So now what client will do now? So client synchronize the VLANs and forward advertisements. So what client is doing is whatever information is coming from server is copying here, synchronizing. Means VLAN 10 VLAN 10, VLAN 20 is copied and update to next client. But actually VLAN 10 for which department? Sales. VLAN 20 for which department? HR. Like in switch B, which department is there? Marketing and IT is there. So VLAN 10, VLAN 20 is no need, not required, and B. But still is being copied. Point number 1. So next point is we required a separate VLANs for marketing and IT. I need a VLAN 50 here, VLAN 60 here. So can I create VLAN 50, VLAN 60 in the switch B? No, we cannot create because that's the client mode, right? Then where you can create? In server switch. In server switch are created VLAN 50 and VLAN 60 for marketing and IT. What server will do? Update to client. Now what client will do? Synchronize 50 and 60. So what client will do now? So 4 VLAN information can be advertised to client C. So what client C will do? So client C is copying 10 and 20. The same time 50 and 60 also has been copied. So VLAN 50 for what? Marketing. VLAN 60 for what? IT. But in C, no marketing and no HR, IT department. So throughout the domain again, throughout the network, it's been copied. So scenario is here, we don't require a VLAN 50, VLAN 16, switch A and switch B. In other switches also, we need only on one switch. So we need VLANs in only one switch that should be not replicated to all clients, all switches. That's how we can do that. And in the VLANs in B only. That VLANs information should not copy to other switches. Only for this switch I require. So in VTP you have one more mode, transparent mode. VTP transparent. So VTP modes are 3 modes: server mode, client mode, transparent. So transparent is similar to server. So where a requirement in switch B, right? In the switch B have configured, I made B is a transparent switch. Now transparent switch is similar to server, means we can create VLANs, we can delete VLANs also. So if we create VLANs or if we delete VLANs, this information will not synchronize in A, it will not synchronize in B. So these VLANs only for local, this is only for switch B. Now if we create VLAN 10 in say VLAN 10 in A, switch A, 20 in switch A. Now what server will do? It will update to transparent. Now what transparent is doing is this VLAN 10 and 20 information does not synchronize. This does not copying here. The same advertisement again will be just forwarded to other client switch. So transparent switch will forward advertisement but does not synchronize. Then which switches will synchronize the VLANs? Server and client only synchronization. So this is VTP transparent switch. Create, delete, modify VLANs only for local switch and local VLANs only. So transparent switch does not synchronize, it forward advertisements. Okay. So VLAN, how VTP works. So VTP server, transparent, client. Now admin here is connected. Admin is connected to server mode switch. And what admin is doing is Admin is adding VLAN 10. He's created VLAN 10. So VLAN 10 sales. It's created. In transparent, in server switch. What server switch will do? Update to transparent. The transparent switch synchronize the VLANs or it just forwards the information? What transparent switch will do now?
Source the information.
It just forwards, it does not synchronize. Update to client, that's it. What client will do? Client will be synchronized and again sending to next page, like that. This is the configuration. VTP mode server, VTP mode client and transparent, VTP mode domain, passwords. So here, so it should be show VTP status, VTP operating mode. What is the VTP operating mode? VTP operating mode is server. Let us give the name for this. Switch A is hostname. Next switch. Show VTP status. This is also VTP operating mode is server. So by default, all switches are server mode. Host name is switch B. Now, let me do one thing. Let me keep switch A as a server switch and let me change switch B as a client mode. VTP mode. Client. Now switch B is a client switch. We check show VTP status. VTP operating mode is what? Client. The when server switch and client switches can be synchronized, server switch domain name and password, client switch domain name and password, the same, then synchronize the VLANs. Let me create the domain name. VTP domain is Cisco. VTP password is CCNA. And so it should be also same thing. VTP domain is Cisco. VTP password CCNA. We can check the domain name, VTP status. VTP operating mode is client. VTP domain name is Cisco. Show VTP password. CCNA. So password is what? CCNA. Now we want to create the VLANs in switch A. Before creating, let me check what are the VLANs we are existing here. Show VLAN brief. VLAN 1, 1002 means 2001. There is no VLANs here. Only you have default VLANs. In switch B, let me check. Show VLAN brief. Show VLAN brief. So here also no VLANs, only default VLANs. And let me create some new VLANs in switch A, the server switch. And VTP works when a link between switch A and switch B should be configured trunk and the minimum speed is 100 Mbps. Let me check trunk is enabled or not. Show interface trunk. See, trunk is not there. If trunk is not there, then even if you create the VLANs also cannot be synchronized. So first let me make a trunk. And which port need to be configured trunk? We can get the information from CDP. Show CDP neighbor. So it should be connected to port number 15. So port number 15 we need to configure trunk. Interface pass Ethernet 0/15. Switch port mode trunk. Only one side of a configure trunk. Other side automatically found. Now if you check show interface trunk is configured. Show VLAN brief. No VLANs here. Yeah, here also no VLANs. Now let me create some new VLANs in switch A. VLAN 111. Name A. VLAN 222. Name B. VLAN 333. Name C. Like I have created 3 new VLANs. Now if we check show VLAN brief, in switch A, 111, 222, 333 has been added, ABC VLANs. In switch B, if we check, if we check show VLAN brief, so switch B got automatic update, advertisement, ABC VLANs is we got. So B got information, so ports will to be implemented manually. And individual switches. Like this, server update to client. Can we create VLANs in switch B? VLAN 444. If you try to create VLAN configuration not allowed when device in client mode. Can you delete VLANs? No VLAN 222. So creating delete is only in client. Sorry, server. In server, we can delete. No VLAN 222. Sorry, 222. So no VLAN 222. Now if we check, show VLAN brief. So we have only 111, 333. Even switch B also if we check, show VLAN brief. Only here 11. So if we create or if we delete, it will be synchronized in all client switches. Now switch B is a client mode, right? Let me make this switch B is in a transparent mode. VTP mode transparent. Now switch B is a VTP operating mode is transparent. Now we can create VLANs in transparent switch. VLAN 777. Name is G. VLAN 888. Name H something. So VLANs is created. Show VLAN brief. So here we have 777, 888 is there, right? So these information will be synchronized in client, in server? No. So 777, 888 only for local switch, only for transparent switch, no synchronization. Okay. This is configuration. VTP mode, server or client, VTP domain, Cisco, VTP password, CCNA, like this. So switch A configuration. And switch B. And switch B, client, meaning is same. Verification. And switch privilege mode. Show VTP status. Show VTP password. Okay. Can you find out in this diagram, in this packet tracer, how many devices there? How many devices in this picture?
Six devices.
Six devices. How many are switches? How many are routers?
4 are routers, 2 are switch.
How we can say 4 routers and 2 switches?
By symbol or
Router icons is placing the symbols in the packet tracer, right? Okay.
correct.
Yeah, in real time, how we can come to know for your office switch, how many devices are connected are there? By seeing the cables, and we can come to know there are four cables are connected, so 4 devices are connected for switch A. But by seeing the cables, can you find out? Can you identify? So there are 3 switches or 3 routers and 1 switch is connected. We don't know how which cable is connected to which router, and which port number is connected to router 1, which IP address on the router 1, and what is the model number of router 1. So you are in switch A, okay, but for your switch, how many devices are connected? And the device information. Can we get this device information? So first device, is it router or is it switch? If it is a router, which model number, which IP address, which iOS version? And LAN port is the Ethernet port or fast Ethernet gigabit port. And this is the router, if it in my switch, which port number is connected. So this is all the information within a 60 seconds we can get, because of in every Cisco switches, CDP protocol is enabled, Cisco Discovery Protocol. So CDP. Cisco Discovery Protocol. The CDP name itself is telling is what? It is a Cisco proprietary protocol. So CDP will discover only Cisco neighbors. It is Cisco proprietary. It is enabled by default in all Cisco devices, means Cisco switches, Cisco routers, Cisco access points, Cisco firewalls. Like all Cisco devices by default is enabled. What the CDP will do? CDP advertisements are sent to all the ports by default for every 60 seconds by using this multicast address. Okay. Advantage what? Once layer 1 is active, CDP sends the information to its active neighbors. In between the 2 devices, layer 1 cable is active. This is my Cisco device. Another Cisco device. Between these 2 devices, layer 1 is okay, cable is okay, that's it. No protocol configuration, no passwords, nothing. Once layer 1 is active, now device 1 will send information to device to switch, and switch will advertise to router. So if you log into router, you can know about switch. If you log into switch, you can know about router. So for the switch, let's consider have a one more device is connected. And between these device table is okay. Then if you log into switch, then you will get two device information. So device one, which port number it is connected. Here it is which port number is connected. And the router is a router or a switch and which model number it is. iOS version, password, sorry, IP address of the router, iOS version of the router, all the information will be. Say for the switch have a one more device is connected. It's even this information also. One more device is connected, switch. Now have login to switch A. Then how many device information we can get? So CDP advertise will be directly connected devices information we can get. So if you log into switch A, now we can get router 1 information, router 2, router 3, and switch information also. So these devices IP address we can get, and those devices host name we can get, and the devices model numbers we can get, which model numbers, iOS version, and port numbers, which port numbers is connected. This all information will get actually. Information advertised by CDP, logical address means IP address if is configured. Host name of the device, hardware platform, like devices are 2000 series or 2800 series, 2960. What is the device exactly? That model number you can get. And iOS version, if it's 12.1 iOS version, 12.2, or if it is a 15.1, like what is iOS version information? Interface type. So device interface is a Ethernet port, or is a fast Ethernet, or it is a gigabit port. Like what is the type of port? An interface number. It is connected to port number 2. It is connected to port number 9. It is connected to port number 11. Which port number is connected? So the device can be local device. It can be remote device. So these information has been advertised by CDP protocol. When a just link is being connected, so configurations is not required, passwords are not required, that nothing. Because of CDP is enabled by default. So let me log into switch A. Now if we check, show CDP neighbor. Only one switch information are getting. Port number 4. Platform is 2960. Why? Because of maybe in 3 routers, CDP is not enabled. See, generally by default is enabled. Maybe I have wantonly disabled actually. Unused services I used to disable. Let me check CDP is enabled or not. But every Cisco devices, CDP by default is what? This CDP is enabled by default in all Cisco devices. Even we want to disable, can disable also. Show running configuration. Yeah. Have you seen this command? No CDP run is configured actually. It means CDP is disabled. We do one thing. Let me enable CDP. CDP run. So CDP is enabled. Now if we check the information, show CDP neighbor. So we got device information here. Host name is Hyderabad. Port number 1 is connected. The capability is a router. And first one is a switch, is a router. Switch model number is 2960. Router model number is 2600 series. Let's enable CDP in next device also, next router also. Config mode, CDP run. Now CDP is enabled. Now if we check in LAN 1, So we got one more device information. Host name is Zoomtech. Port number 2 is connected. Is also router. Same model 2600 series. Let me enable here CDP. CDP run. Now if we check show CDP. Yes. So 3 routers, 1 switch is connected. These routers, this device is IP address information where you can get. So this device iOS 1 information you can get. Same command, show CDP neighbor detail. Switch entry IP address means IP is not assigned. If it's next device ID Hyderabad router, IP address is 10.1.1.1, platform is Cisco 2600, capability is router, port number 1, enter, iOS version is 12.2. Like all the details you can get, all the device information here. Okay. CDP protocol by default is enabled. If it is disabled, to enable that, you can use command is CDP run. Configuration mode, CDP run. When you disable, you can use no CDP run. Verification commands, show CDP neighbor, show CDP neighbor detail. Like this. Any doubts? about CDP? Yes, please. Right. Disadvantage of CDP is CDP can discover only Cisco devices. Then what if you have a non-Cisco device in your network? Other vendors? CDP can be used only between the Cisco devices. Go back. Moreover, CDP can discover only directly connected information, directly connected devices information can be known. So what if you have a non-Cisco device in your network? I'll go with next protocol is LLDP. Link Layer Discovery Protocol. Okay. So LLDP is open standard protocol. Compared to CDP, LLDP is a faster. Like CDP advertisement, you can get 60 seconds, right? LLDP advertisement 30 seconds. And Cisco devices by default, it is disabled. CDP is enabled by default in all Cisco devices, but LLDP is disabled. We need to be manually enable it on Cisco devices. Then how can enable it? LLDP. LLDP run. To disable it, no LLDP run. Verification, show LLDP neighbors. Show LLDP neighbor detail. So this is the configuration for CDP. And the configuration for LLDP. So just we can change CDP into LLDP. Okay. So both are discovery protocols. CDP Cisco protocol, LLDP is open standard protocol. Let's see next scenario. Like for device 1, for port number 1 of the device, have connected one computer, port number 2, port number 5, port number 6. Port number 1, 2 ports are sales department. Next to our HR department. Like 1, 2 network is, they are in 1.0 network. They are in 2.0 network. Now 1, 2, then sales department are in VLAN 10. These are in VLAN 20. From in this scenario, sales department, HR department, will they communicate? No, because of different VLANs. Then how can forward the different VLAN communication? How we can allow different VLAN communication is by using layer 3 device, we can forward the traffic from one VLAN to another VLAN. So layer 3 device is what? Router or L3 switch. If you have a router, by using router, we can enable different VLANs communication or layer 3 switch also. First, we'll see about router. I'm using router. So whenever we use the router means, routing table will come in the picture. This is routing table. By default is empty routing table. Okay. I connected one cable from the router to port number 3. From router fast Ethernet port FE0/0 and fast Ethernet 0/0 have assigned IP address in 192.168.1.1 network. Then your routing table has been updated. What is updating routing table? So on fast Ethernet network says 168.1.0 is directly connected to FE0/0. Now VLAN 10 users is trying to communicate with VLAN 20. Traffic is being generated. Source is 1.10. Destination is 2.0 network. Traffic is generated. Come to router. What router will do? So router always will check routing table. The routing table, if destination IP address is available, it will forward it. If destination is not available, drop it. So destination is not there now. Then what router will do? Drop it. Then when your packet is being forwarded, even VLAN 20 network information also should be there, right? So let me add it. How I'm adding is I'm using one more interface from router and connect to port number 4. It says FE0/1, port number 1 I have connected. For port number 1, I'm using network is 2.1 IP address I have assigned. Then routing table update. 192.168.2.0 is directly connected to FE0/0. Then what we need to do means we need to make the VLAN 10. Port number 1 is a VLAN 10. Port number 2 is VLAN 10. And where exactly a fast Ethernet port is connected on the switch? Port number 3. So fast Ethernet we have assigned 1.1. This interface where you have connected port number 3. So port number 3 also should be part of your VLAN. VLAN 10, 1, 2, 3 ports are VLAN 10. Similarly, 4, 5, 6 are VLAN 20. This is the diagram. So now 1, 2, 3 belongs to one domain, 4, 5, 6 is another domain. Now PC1 user want to communicate VLAN 20 user. Source is 1.0, destination is 2.0. Packet is generated in first PC. What first PC will do? Will come to traffic to port number 1. And port number 1 broadcast to how many ports? Within the VLAN broadcast. So broadcast to port number 2, broadcast to port number 3. Now what port number 3 will do? Where exactly port number 3 is connected? This means broadcast is going to router. Now packet is being received by router. What router will do? We'll check the routing table. Okay, 1.0 traffic is coming. Way to reach destination 2.0. How to reach 2.0? FE 0/1 is a 2.0. Fast Ethernet 0/1. So now traffic is been switching to fast Ethernet 0/1. So fast Ethernet 0/1 connect to which port number? Port number 4. So port number 4 broadcast to 5 and 6. They can communicate. So this is how traffic is forwarding from one VLAN to another VLAN by using a router. So this process we call routing between the VLANs. IVR, inter-VLAN routing. Inter-VLAN routing is a process of forwarding traffic from one VLAN to another VLAN by using a router. Okay. Inter-VLAN routing is a process of forwarding a traffic from one VLAN to another VLAN by using a router. All right. Any doubts here? So how we can enable communication for different VLANs is what? This is the process by using router. Yes, please. Any doubts? Right. So here, two different VLANs we have enabled communication, right? For two different VLANs, how many router ports are being used? How many switch ports are being used? How many cables are being used? Router ports. FE 0/0, FE 0/1 means two ports are being used. Switch ports. Port number 3, port number 4 means two ports are being used.
Yes.
How many cables are used? Two cables. So for two different VLANs, two router ports, two switch ports, two cables are being used. Now what if I have a 10 different VLANs in my network and I want to allow 10 different VLANs communication? Then how many router ports are required? 10 router ports, 10 switch ports, 10 cables. Problem. So this is not a best practices. So it's one of the possibility only actually. Then which method we use the real-time means? Same scenario. VLAN 10 and VLAN 20. And I'm using router. Router with only one physical link. Only one router port. Only one switch port. Only one cable. Just I'm using FE 0/0 only. Then what about your routing table update? So one physical interface, fast Ethernet 0/0. From that, we can create multiple sub-interfaces. So FE 0/0.1 enable encapsulation to allow the multiple VLAN traffic. Encapsulation .1Q for VLAN 10. Can assign IP address 192.168.1.1. So 1.1 for VLAN 10 and IP address. Next, FE 0/0.2 enable encapsulation .1Q for VLAN 20. IP address 2.1. Like one physical interface, we can create multiple sub interfaces. Each VLAN is associated with one sub interface. So how many VLANs you want to enable communication? That many sub interface we can create. N number of sub interface we can create from one physical port. So now your routing table is updated with networks. So and so network 1.0 is directly connected to which interface? 2.0 is connected to which interface? FE 0/0.1. FE 0/0.2. So routing table is updated now. Main point is router and switch, which port is connected? The port where router is connected in the switch. The port where router is connected on the switch. Port number 3. If port number 3 is a access port allows how many VLAN traffic? Only one VLAN traffic, right? But here requirement is what? VLAN 10, VLAN 20, VLAN 30, multiple VLAN traffic. So the port where router and connecting the switch, that port should be configured trying to allow multiple VLAN traffic. So port number 3 should be configured trying to allow multiple VLAN traffic. So VLAN 10 will come to port number 3. Port number forward to router. Router will check the routing table. Again, traffic will come to port VLAN 20. So is the first method. Second method. Can read this? Port where router is connected in the switch should be configured as trying to allow multiple VLAN traffic. One physical interface. Physical interface on router is divided into multiple sub-interfaces. Each sub-interface is associated with one VLAN and one IP subnet. This process also we can call router on stick. Means symbolically, router on stick means one interface, sub-interfaces. So this is also called as what? Router on stick. Yeah. Let's see how to practical. Sub-interfaces. So first three devices are in VLAN 10, VLAN 20. First let we create the VLANs. VLAN 10 name, sales, VLAN 20, name HR, interface range, fast Ethernet 0/123, switch port mode access, switch port access VLAN number 10. Interface range, fast Ethernet 0/527. Switch port mode access, switch port access VLAN number 20. Then now let me take a router. Connecting a link from router fast Ethernet 00 port to switch port number 18. Now log into router. By default, fast Ethernet 0/0 is a shutdown. Just give the no shutdown. Let me create a sub-interfaces. Interface fast Ethernet 00.1. Enter. What is this? Sub-interface. In sub-interface, encapsulation .1Q for 10. IP address like this, like that. Fast Ethernet 0/.2. .1 encapsulation IP address.
Balu, this is a virtual interface, is it?
Yeah, sub-interface. Because we have created virtual LANs, VLANs is also for virtual sub-interface.
Only this is applicable in such kind of scenario, or we can use this in any other place?
This scenario only.
Okay.
Encapsulation for 20. 2.1. So like sub-interfaces are created. Now if you check routing table, show IP route. The routing table is updated with 1.0, 2.0, .1.2. Main logic is router and switch which port number is connected. That port should be configured trunk. Can read this point? The port where router is connected in the switch should be configured trunk to allow multiple VLAN traffic. So router, the switch which port number it is connected, guys? How we can know that? Which port number is connected?
CDP or LDP?
Yes.
CDP.
CDP. So take the CDP help. show CDP neighbor. Yes. Port number router is going to which port number? Port number 18. So let me configure port number 18 is a trunk. Interface FE0/18. Switch port mode trunk. So trunk is configured. Now let me check. I have to change the IP addresses for computer. Like VLAN 10 IP is what? 1.network. 1.10. Gateway subinterface IP is the gateway. Here 2.network. VLAN 20 is 2.network. 2.1. So this PC is VLAN 10 PC is a VLAN 20 PC. Let me check communication now. VLAN 10, VLAN 20. So failed. One more packet. VLAN 10, VLAN 20. It's a success. Say from VLAN 10 traffic is generated. Will come to trunk port. Trunk port will send it to router. Router will check the routing table. Sub interface is A. And router will send it back again. Trunk port to end user. And end user will give the reply. VLAN 20 user reply started. Again back to router. And device. Like this. So this is how we can enable communication between two different VLANs in the two methods. And one more method is router is not required. Scenario 1, scenario 2, scenario 3 router is not required. Just if we say layer 3 switch, directly we can create interface VLAN 10 IP address, interface VLAN 20 IP address. It can be communicated because of layer 3 switch maintain the routing table. It has a switch itself maintain the routing table. Router is not required. Okay. So these are the methods we use to make a routing between the VLANs, inter-VLAN routing. So finally, today we have clearly discussed about VLAN Trunking Protocol, Cisco Discovery Protocol, Link Layer Discovery Protocol, and inter-VLAN routing methods, IVR. Any doubts about this? So try to practice on it and these protocols. If you have any doubts, let me know it. But tomorrow we'll continue with one more. Almost tomorrow we'll end up with the LAN technologies, and the day after tomorrow we'll start with security sessions, Cisco Security.
Balu, I have a doubt, Balu.
Yeah, please.
For voice, VLAN is different.
Voice, the process is the same, voice VLAN. Like how you
Okay.
create the data VLANs, voice VLAN is the same.
And how
Yeah,
how
done.
this trunk?
Yeah.
Yeah, you continue.
This is your switch. Port number 1, port number 2, port number 3, port number 4, 5, 6. The first user is connected to port number 1. Means port number 1, what is the device is connected? PC, computer is connected, right? From port number 1, a user can send data traffic. So port number 1 is sending what? Data traffic actually. Now for this user required IP phone. They're using IP phone. So the IP phone should be part of a network. Then what IP phone is doing is connect to port number 2. Now port number 1, data traffic is going. Port number 2, voice traffic. Now let me make a VLAN 1, port number 1, port number 2 isn't one VLAN. Both are the same VLAN. Like this we can configure. Interface pass Ethernet 0/1 2 ports are in VLAN 10. So IP phone and user both are in the same VLAN. One port for data, one port for voice. But what about having one more user? User 2. For user 2 required IP phone, and they connect to port number 4. So port number 3 data, port number 4 voice. For user 3, you have 10 users. So 10 ports for data, 10 ports for voice. So 20 ports are being used. This is not recommended actually. Then what we'll do means end user connected to IP phone. And IP phone is connected to port number 1. So for port number 1, how many devices are connected now? IP phone is connected and your user is connected. So user is sending a data. IP phone is sending a voice. So port number 1 has to be in forward data traffic also, voice traffic also. So by default, port number 1 will forward data traffic only. Now voice traffic we need to be allowed to by creating a voice VLAN. So if we create the voice VLAN, then port number 1 can allow voice traffic also. Interface fast Ethernet 0/1. Switch port mode access you have made. Switch port access VLAN 10. Okay, now port number 1 is a port of VLAN 10. Switch port voice VLAN for VLAN 20 or VLAN something VLAN 100. So now port number 1 is a part of VLAN 1 and VLAN 100. So VLAN 10 for data. Access port means what data? Voice is voice traffic. Like we can create the voice VLANs. Now port number 1 is sending a voice traffic also, data traffic also. So this is how we can create voice VLANs. Okay.
Thank you, Balu. And one more question, Balu. This trunking we can do it even for Hyper-V and VMware. How can you just explain that too?
That VMware is a VMware trunking is a different. The switches we are inside the switch, Cisco switches we are doing the trunking, right? So
Okay.
when we are connecting two switches in the Hyper-V and VMware, that is a bridging method will be different.
Okay.
So
Thank
you should know about Windows administration. Then we can do that. Or VMware, if you know that, we can do. This is only for Cisco switches trunking we are doing.
Okay. Thank you. Thank
Yeah.
you.
All right. Any more doubts? Right.
Can you copy that voice commands also onto this chat, please?
Yeah, I have shared in the chart.
Thank you. Thanks.
Yes. Like tomorrow, we'll continue with some more loop avoidance protocol, and we'll end up with the LAN technologies tomorrow. And day after tomorrow, we'll continue with the Cisco security sessions. Thank you. Have a nice day.